recordings will be helpful for the revision purpose. So in today's class, we are going to discuss about the converse of Pythagoras theorem. Up to the previous class or in the previous video, we have discussed what is Pythagoras theorem. Let's see what is its converse. So, converse of Pythagoras theorem. Converse of Pythagoras theorem. This is our topic for today. Now, in order to prove this converse of Pythagoras theorem, you need to have a big idea about the congruency of triangles. In class 9, chapter 7, geometry, we have studied about congruency of triangles. Okay? So we are going to utilize some of those ideas, some of the concepts related to the congruency of triangles. Also, we need to have a clear idea on the Pythagoras theorem, which we have already discussed in the previous class. Okay. I have also uploaded that video in the YouTube, so you can always search by typing Pythagoras theorem by Samrat. Is it okay? Then on the YouTube it will be available. Okay. So I'm saying this because it is important for your revision purpose. All right. Yeah. Everything that we have learned, everything that I have taught you, okay, things has to be constantly revised. So, converse of Pythagoras theorem. See, in Pythagoras theorem, what was given? In Pythagoras theorem, what was given? A right triangle was given, right? When we talk about Pythagoras theorem, then in Pythagoras theorem, a right triangle was given. A right triangle was given, and you have to prove that square on the longest side or square on one side is equal to the sum of squares on the other two sides. Okay, so what was given in Pythagoras theorem? A right triangle ABC was given. A right triangle was given, and we proved the condition that square on one side is equal to the sum of squares on the other two sides. So a right triangle was given, and we proved this one. In the converse of Pythagoras theorem, we will reverse the things. Whatever was given in Pythagoras theorem, that we have to prove here. And whatever was required to prove in Pythagoras theorem, that will be given here. Is it okay? Are you following that? Yeah. So in converse of Pythagoras theorem, what will be given? This condition will be given to you. And using this condition, you have to prove that that particular triangle is a right triangle. Are you following that? Let me repeat. Whatever was given in Pythagoras theorem, that condition we need to prove here. And whatever was required to prove in Pythagoras theorem, that condition will be given. It's just the reverse. It's the converse. We call this as converse in mathematics. So, in converse of Pythagoras theorem, what will be given? In any triangle, say ABC, in any triangle ABC, say, square on one side is equal to the sum of squares on the other two sides. This condition will be given to you. In a triangle, square on one side is equal to the sum of squares on the other two sides. This will be given to you. And you are required to prove that this particular triangle is a right triangle. Means the the angle which is opposite to your longest side will be a right angle. So you have to prove that angle A is 90 degrees. Or triangle ABC is a right triangle. So this is what you want to prove. Whatever condition was given in Pythagoras theorem, that you have to prove here. And whatever condition was required to prove in Pythagoras theorem, that will be given in this converse of Pythagoras theorem. Okay. In Pythagoras theorem, a right triangle was given, but in converse, you have to prove that this particular triangle is a right triangle. In Pythagoras theorem, you need to prove that square on one side is equal to the sum of squares on other two sides. In this theorem, that condition will be given. Is it okay? So, in converse of Pythagoras theorem, so question can be asked, state and prove Pythagoras theorem. Statement will be for 1 mark and the proving part will be for 4 marks. Okay, so question can be asked, state and prove Pythagoras theorem for 5 marks. So we need to remember the statement. See, remembering the statement is very simple. Whatever condition was required to prove in Pythagoras theorem, that condition will be given here. Whatever condition was given in Pythagoras theorem, that condition you have to prove here. So you just reverse the statement of Pythagoras theorem. So this converse of Pythagoras theorem states that in a triangle, not a right triangle, okay? In a triangle, if the square on one side is equal to the sum of squares on the other two sides. Let me say it by drawing the figure. So any triangle, this is any triangle, say XYZ, XYZ. So this is any triangle. So in a triangle, the square on one side will be equal to the sum of squares on the other two sides. Okay, so this condition will be given to you. You will be required to prove that the angle which is opposite to your longest side is the right angle. So to prove that angle Y is 90 degrees. This is what you have to prove. This is what will be given. Okay, this is what is given and you will be required to prove this. That means XYZ is a right triangle. Okay, so you just make this mathematical thing in the form of a statement. So converse of Pythagoras theorem says that in a triangle, if the square on one side is equal to the sum of squares on the other two sides, then the angle opposite to the longest side is a right angle. Okay, so that is the statement of Pythagoras theorem. I will write it on the board. Okay, you can follow it up. In a triangle, if the square on one side, if the square on one side is equal to the sum of squares, is equal to the sum of squares on the other two sides, on the other two sides, then the angle opposite to the longest side, then the angle opposite to the longest side, is a right angle. So it's very simple to prove this. Okay, you need to have a clear concept on Pythagoras theorem. You need to understand what is Pythagoras theorem, which we have learned, And also you need to understand a bit of congruency, which you have learned in class 9. Okay, chapter 7, triangles. So this is what the theorem is all about. So if you are done, I can just remove this statement. Is it okay? I will just remove this statement. Okay, so let me start with the proof here. So in this theorem, what is given? What is given? In a triangle, this is not a right triangle, okay? In a triangle, let me draw the triangle in this way. Let me just draw the triangle in this way. Okay, in a triangle ABC, this is not a right triangle, we do not know. I have drawn what I have done here is I have drawn an ordinary triangle. I cannot say whether this is a right triangle or not, okay? We have just taken a random triangle drawn in this way. You could have drawn in any way you like, okay? So I have drawn in this way. You can draw in any form. So what is given? In this particular triangle, given, in this particular triangle ABC, the square on one side is equal to the sum of squares on the other two sides. So this is what is given. So in any triangle ABC, square on one side is equal to the sum of squares on the other two sides. So this is given. So as it is given, a relation is given. So I will mark this as equation number 1. Is it okay? Now, since this information is not enough, so I have to do some additional thing. So if you do any additional thing, if you introduce any new things in this theorem, then that is going to be your construction. Construction means you write something or you draw something extra apart from what is given. Then that is going to be your construction. All right? So let us do some construction here. Before that, what do you want to prove? You want to prove that the angle, this angle, which is opposite to your longest side, is a right angle. So you are required to prove that angle B is 90 degrees. Angle B is 90 degrees. That is what we want to prove, which was actually given in the Pythagoras theorem, right? Yeah. Now, let us do some construction here. Construction means you do something extra apart from what is given. That is your construction. So in the construction, what I'm going to do is I'm going to draw another triangle on our own. But you just make sure that the triangle is a right triangle. Okay? So I'm going to introduce another triangle. Name it as PQR. But you make sure that this is a right triangle where the right angle is at Q. So construction. Draw a right triangle PQR where angle Q is 90 degrees. So that is our construction. Not only that, after drawing this triangle, make sure that the side PQ is equal to the side AB. We can do that. This is something we are doing on our own. Is it okay? So in construction, what you need to do is you draw a right triangle. On your own, you just draw a right triangle, but make sure that the length, the side PQ, is equal to the side AB. Also make sure that the side QR is equal to the side BC as well. So that's our construction. That is the extra thing that we are introducing. Also, while drawing this triangle, make sure that the side PQ is equal to your side AB of the given triangle. And also make sure that the side QR is equal to the side BC of your given triangle. So that is our construction. So our construction is, we have drawn a triangle PQR, making sure that this is the right triangle. Also the side PQ is equal to AB and the side QR is equal to BC. Now class, look at the figure and answer this very carefully. Which among the two triangles is the right triangle? You can please comment on the chat here. Look at the figure and answer which among the two triangles is the right triangle. So yes, I have two comments here. Three comments, okay, correct answers. Among the two triangles, PQR is the right triangle because we have constructed accordingly. Your ABC is a given triangle. We cannot say whether this is the right triangle or not. But in our construction, we make sure that we have drawn PQR in such a way that it is the right triangle, right? So correct. So among the two, PQR is the right triangle. And since PQR is the right triangle, we can apply Pythagoras theorem. PQR is the right triangle, so we can apply Pythagoras theorem in this particular triangle. Are you clear with that? Yes. So, okay, our construction was such that PQR is a right triangle, right? And since PQR is a right triangle, so we apply Pythagoras theorem over there. In right triangle PQR by Pythagoras theorem. By Pythagoras theorem. Now this Pythagoras theorem says that square on the longest side is equal to the sum of squares on the other two sides. That's your Pythagoras theorem. So we apply Pythagoras theorem in this right triangle. So as PQR is a right triangle, so by Pythagoras theorem we have square on the longest side, that is PR. How do you identify longest side? The side which is opposite to your right angle is the longest side. Okay. So the square on the longest side is equal to the sum of squares on the other two sides. That is PQ square plus QR square. Is it all right? Now let me solve this. PR square is equal. Now look, class, look here. Look at the board. In our construction, we have made the side PQ to be equal to AB, right? In our construction, we have drawn the side PQ to be equal to AB, right? So this PQ can be replaced by AB. And as we have PQ square, we can write AB square. How comes PQ is equal to AB? By construction. We have constructed this triangle PQR in such a way that the length of PQ is equal to AB. The side PQ is equal to AB. So we are applying the construction over here. This triangle is drawn in such a way that the side PQ is equal to the side AB. Okay. Also, we have drawn this triangle in such a way that the length of QR is equal to the length of this triangle BC, the length BC of this triangle. So according to the construction, QR can also be replaced by BC and we have square over there. Is it okay? Now, PR square is equal to, now we have on the right side, we have AB square plus BC square. Now look at what is given. Look at Look at equation 1. This equation was given in this theorem. This equation 1 is given. What is given? AB square plus BC square gives you AC square. So using equation 1, what I can write is AB square plus BC square will always give you AC square. Is it okay? That is what we can write here. Now we can cancel out the squares from both sides. So what do we get here? PR must be equal to AC. So in our construction, this triangle was made in such a way that the length of PQ and AB are equal. The length of QR and BC are equal. But we had no idea about PR and AC, right? We had no idea about PR and AC. Now we have also proved that this PR is equal to AC as well. That means all the sides of this triangle are equal to the sides of this triangle. That means these two triangles are equal in size. See, the length AB and PQ are equal. That is how we have done. The length BC and QR are equal. Okay, that is how we have drawn. But we had no idea about AC and PR. We had no idea about AC and PR. But now we have also proved that the length of the third sides are also equal. The lengths of the third side are also equal, which makes triangle PQR and triangle ABC not only similar but equal in size as well. So if two triangles are similar and have equal size, then they are said to be congruent. They are said to be congruent. I'll give you an example. Okay, the two palms of my hand. Okay, my left hand has 5 fingers. We have the thumb, the forefinger, the middle finger, the little finger. Is it okay? In my right palm also, I have all these 5 fingers. All these 5 fingers. Okay, the two palms of my hand, they're equal in size. They look alike, and as they get closer to each other, okay, they just exactly cover each other. So the two palms of my hand are congruent. That is the meaning of congruent. Similar and equal in size. Now here in triangle ABC and PQR, we have seen that all the sides are equal. Thus, all the sides of this PQR is equal to all the sides of this triangle ABC. That makes the two triangles to be congruent. Is it okay? So when I compare these two, in triangle ABC and triangle PQR, okay, when I compare these two triangles, the length of AB is equal to PQ. That is by construction. Okay, we have drawn this PQ triangle in such a way that the length PQ was equal to AB. That is by construction. We have also drawn this triangle in such a way that the length of QR and BC was equal. BC is equal to QR. And now finally we have proved that the third sides are also equal. The length of the third sides are also equal. So we have also proved that AC is equal to PR. That is what we have proved. The first two is by construction. The last one is proved, already proved. Proved above. We have proved above. So all the sides of the two triangles are equal. The three sides of the first triangle are equal to the three sides of the second triangle. So that makes the two triangles not only to be similar but equal in size. It means therefore triangle ABC is congruent. This is how we write congruent. Congruent means similar as well as equal. So see, triangle ABC is equal to triangle PQR, not only equal but similar also. So this is how we write congruent. Okay? There is side criteria. by side criteria. Is it okay? Now, if two triangles are congruent, then all their corresponding angles will also be equal. That is what we call it as CPCTC. Corresponding parts of congruent triangles are also congruent. CPCTC. Okay, in short, we say abbreviation. Corresponding parts of congruent triangles are also congruent. So all the sides of these two triangles are equal, so they are congruent. So if they are congruent, then all their corresponding angles will be equal. Here, the angle Q of this triangle PQR corresponds with this angle B of your triangle ABC. So this gives you angle B and angle Q to be equal. And since angle Q is 90 degree, so angle B will also be 90 degree. That is your CPCTC. Corresponding parts of congruent triangles are also congruent. So this is our desired result. This is our required proof. So we needed to prove that angle B is 90 degree. So we have proved here that angle B is also 90 degree, which completes the proof of the converse of Pythagoras theorem. So question can be asked, state and prove converse of Pythagoras theorem. Then this is exactly what you need to write in your examination. This is exactly what is given in your textbook as well. Is it okay? So you can take your time to copy this down.